All right, let's get zoomed in on the right spot here. So section 6.3 is going to start talking about logs. So in your notes, you're going to see the logarithm page and all that good stuff. Okay, so what is a log? A logarithm. So it's going to be a math function, and a logarithm is the inverse of an exponential function. It's the opposite of an exponential function. The opposite of adding is subtracting. The opposite of multiplying is dividing. The opposite of squaring something is the square root. So the opposite of an exponential function is a logarithm. So these two things cancel each other out, or they're inverse operations. So logs answer the question, what exponent? Logs answer the question, how many? So just like in an exponential function where we have a base, logs are going to look weird to you, but they're not a difficult concept. It's just they look different. So everything before me you've probably heard of before, and this is probably like the first topic where maybe you've never heard of these things. So here's what a log looks like. So that's a log, okay? This says log base of 25, or log 5 base 25, okay, is equal to what? So when we look at this, 5 is our base, and what we call 25 is our argument. So 5 is considered the base, and what the 25 is considered is it's considered the argument. Okay, so much like when you guys dealt with exponential functions and we had an a value and we had a b value, here we also have an a value and a b value, and the b value is still the base. So as I look at this, here's my b value. We're trying to figure out what this thing equals. So we're trying to say log base 5 of 25, okay? And that's how we're going to read it. So another thing that's kind of confusing to people is, how do we say this? Well, we say log base 5 of 25 equals, and we got to figure out what that thing equals. So this is the most confusing part, is the fact that there's no symbol for logs. Is there a symbol for logs? Nope, we just use an abbreviated word as part of it. So the answers to logs are what? How many? What? What exponent? So using the base, how many 5s does it take me to get to 25? What exponent would I use with 5 to get to 25? So when I answer this, the answer to this log problem is 2. Because with 5, what we can do is 5 to what power equals 25. Logs answer the question, what exponent? And the exponent with 5 that I would have to use is 2. 5 squared is 25. What exponent with 5 would get me to 25? Well, the exponent would have to be 2. 5 would have to use an exponent of 2 to get to 25. So the answers to logs are, what exponent would you use? What exponent would you use with the base to get to the argument value? So what some kids do, and they see that, is logs are confusing to them. So what some kids do is they go, well, that's kind of confusing. I have a hard time reading this. So if they get confused with the log problem, what you can do is you can rewrite it. And you can rewrite it in what's called exponential form. So the one that I have written up top, up here, this guy is in what we call log form. Log form has the word log in it. This down here is called exponential form. They both represent the same thing, but one is very, I shouldn't say very, but it's easier for kids to see answers and adults. But logs are kind of hard. Why are they hard? They're hard in the fact that maybe you see that word and you get confused. The math is not hard, but the actual fact where you see this log base 5 of 25, oh my goodness, that looks crazy. So you want to think of logs in terms of what exponent, when I use it with the base, will get me to the argument. How many 5s does it take to get me to 25? Okay, so as you guys look at that, and let me zoom in closer here on the bottom as you see my desk. So if you're given log base 5 of 25, and we already know the answer is 2, because we know the answers to logs are exponents, another way you can look at it as, how many 5s does it take to reach 25? Well, I know 5 times 5 is 25. Now the answer here is not 5. Why is the answer not 5? Because I already know what times what is 25. But I need to know how many 5s did we use. We used 2 5s to get to 25. So that's why the answer is 2, because that's how many 5s we used. Okay, it's not what times what, it's how many of the base did I use to get to 25. So as I look at that, and all these other things that we may talk about, is we're just trying to answer the question, how many? How many? What exponent would I use? So if my exponent isn't listed there, and it's listed in log form, then what we got to try to figure out is we got to try to figure out what times what times what, or how many of that does it take to get there. Okay, so let's think of this. The answers to logs are exponents. The answers to logs are exponents. So if I need to think of that, and you're having a hard time when it's written in log form, then what I would recommend you doing is write it in exponential form. Okay, so log form is going to have 3 spots when you guys fill in those blanks for log form. It's going to have the number here at the base, it's going to have your argument number, and that's going to have whatever it equals. So remember, the number down here is going to be considered the base. It's going to be considered the base, and this is going to be considered the base. So we have 3 examples there. One with base 7, one with base 3, one with base 9. Here we have what's called the argument. Okay. Now, after a while, I don't even know if you really want to call it that. After a while, we just call it the A value. I may say argument. I think I say A value a lot though. Okay. And then we have whatever this is going to be equal to. Now remember, those are going to be whatever exponent I would use to 7 to get to port 49. Whatever exponent I'd use to 3 to get to 27. What exponent would I use with 9 to get to 81? So if you get confused by log form, then what I recommend doing is writing things in exponential form, because that may make it easier for you to process. How do you write things in exponential form? Give it 3 blanks. Okay, a main box, an exponent, and it equals another box. So we're going to do that with all 3 of them, so you can look at it, because sometimes people aren't good with logs in their brain because it just seems weird to them. So if you're not good with logs, then what you can do is you can rewrite them. And kids, all of your notes, like this section of notes, it's going to be talking about that. Hey, it's another way of writing exponents. Hey, write each equation in exponential form. Hey, write each equation in log form. Hey, evaluate these. Now you notice this, log base 7 of 49, log base 7 of 49. Yeah. So I'm just pulling them off there. I just want a bigger space of paper to kind of like show these things as they roll. Okay. So the base, which I'll highlight the base in pink, the base is going to stay the base in the exponential problem. So if that's the base of the log, it's going to stay the base of the exponent. the base is at the bottom. So if the number is here at the bottom of the log, the base is going to be the number at the bottom of the exponent. So I'm going to highlight that in pink so you guys can see, okay, so that's going to be where the base goes, is right there. Terrible coloring. I'm staying outside of the lines most of the time because I'm not a very good colorer. All right, now what logs are going to be equal to is they're going to be equal to their exponents. So whatever the log equals is going to go in for the exponent, and the argument is going to get separated from the base. So in exponential form, you're going to put the argument over here, and I'm going to call it the a value. So we're going to separate them because in the form that they're in, we're not seeing the answer. So what we're going to do is we're going to take that value and we're going to separate it when I write it in exponential form. So the 49, the 27, and the 1 over 81 are going to go right here when you rewrite it. Remember, we're just rewriting it. It's just like in elementary school or middle school or high school. I don't know what you do and when you do it. When you rewrite a sentence, that's what we're going to do. So the base is going to go at the bottom. So 7 is going to go at the bottom. The argument's going to get separated from it. The 3 is the base. The argument's going to get separated from it. The 9 is the base. The argument's going to get separated from it. Okay? So what does that mean? That means whatever our exponent is, logs are going to equal the value of the exponent. So whatever that answer is for the exponent, that's going to be the answer for your log problem. So can you figure these out? If you can't figure out this way, then think of it this way. 7 to what power is 49? Yes, I agree with you. Good job. 7 squared is 49, so that means this problem is equal to 2. Log base 49, or log base 7 of 49 is equal to 2. So the answer should be 2. You may not see it in log form, so rewrite it in exponential form. Log base 3 of 27 equals what? I don't know. So what did we do? We rewrote it. 3 to what power is 27? 3 times 3 is 9. 9 times 3 is 27. How many 3's did I use? I used 3. So since my exponent would be 3, my answer to that log problem would be 3. So if you struggle with stuff in log form, put it in exponential form. Okay? All right. 9 to what power equals 1 over 81? Or 9 to what power would give us this argument value? Oh my gosh, sometimes that's hard for kids. Okay, remember, 81, we can get to 81 with 9 because I know 9 squared is 81. But I want a fraction. Well, how did we get a fraction? What kind of exponents give us fractions? Remember, negative exponents will give us fractions. So 9 to the negative 2 power will give us 1 over 81. So as you look at this, the value of this log, and that's what we talked about in, when was that? Was that chapter or section 5? This has been a weird year, okay? So what I want to look at is I want to figure out what 9 to the negative 2 power is, and that will be 1 over 81, okay? So don't forget negative exponents. Negative exponents don't give you negative answers. Negative exponents give you fractions. So if you ever see that I have a fraction right here, what is the answer to logs going to be? Well, when your base is 9 and I have a fraction for 1 over 81, your answer is going to be negative. Instantly, I know that. Okay? I know my answer is going to be negative. So if I have log base 2 of 1/8 and I want to know what that equals, and somebody's like, oh man, Thrasher, that's a log problem. I got a fraction in there too. You're really messing me up. Then what would I do? I would tell you, hey, go think of it in terms of exponent form. 2 is my base. The a and the b value are going to get separated. How would we get 8? What exponent would I use with 2 to get 8? Well, you'd have to use 3 because 2 to the third is 8. But I don't want 8, I want 1/8. So what exponent would I use? I would use negative 3. Okay? So has to be, notice, when you get a fraction here, your answer is going to be negative. Okay? And I did all the same stuff. I put the base in the same spot. Base went right there. I just highlighted red with pink. I'm so smart. And then my argument, when I put it in exponential form, gets separated. Great. So I put that there. And, oh yeah, whatever my value of my exponent's going to be, that's going to be what my value of my log equals. So the answers to logs are what? The answers to logs are what exponent would I use with my base to get my argument value. Okay? Now, am I always going to be able to do those by hand or in my brain? No, but you can't do all math in your brain anyway. Okay? 149.678 times 272.419. I can't do that in my brain. At some point, I'm just like, oh, that's too much. I'm going to have to use a calculator. Okay? So, we'll show you how to do logs on a calculator as well. Okay? But you can answer these questions now. I can? Yep. What is a logarithm? Well, what is a logarithm? It's an inverse of an exponential function. Okay? So remember, we talked about that on that front side of that paper that we just talked about. Okay? A log is another way of writing exponents. So you have two forms. We just talked about this. You got stuff in log form, you got stuff in exponential form. And what I always do is I always create like 3 little blanks. I know it seems like so elementary. It's like, oh, look, 3 little blanks. Just rearrange them in the right spots. Put your blocks in the right spots. But really, that's all we need you to do. Okay? So our base, I highlighted our base in pink. So we know the base of our log is going to stay the base as our exponential form. I should probably give my exponential form my 3 little blanks. An exponent box equals the a value box. The a value is going to get separated from the b value because it didn't work in log form, so we're going to put it there for exponential form. And what do logs equal? Logs equal exponents. So whatever the exponent is going to be the same thing that the log value equals. So on number 1, it says write each equation in exponential form. Okay, this is log form, exponential form. Oh yeah, Thrasher said make the 3 little blanks. He said it's probably going to look like elementary school where we just have to kind of fill in the blanks, which it is. It's a way harder concept, but when you rewrite it, don't make it that way. Remember, the base is going to go here. You're going to separate the argument from the base, so the argument's going to go on this side of exponential form, or the a value, whatever you want to make reference to that is. Whatever your logs equal, that's going to be your exponent. So just write this in exponential form. Yep, 3 is my base goes here, 9 gets separated, what goes there? 2, this is in exponential form, I'm going to abbreviate that, and this is in log form. Okay? Did they ask us to do anything on that? No, they're just saying rewrite them. Why? Because when we get to solving equations, you got to know how to rewrite them. It's going to make your life a lot easier. Okay? Now, can you work your way backwards? On the next section of stuff, it's going to say go from exponential form. It's going to say go back to log form. So you're going to have your 3 little blanks that you're going to have to fill in, but in log form, you're going to need the word log, and you're going to have to fill them in. So are you going to be able to go from here back to this? Hopefully so, because if you look at number 7, that's what they want you to do. Okay? So I need it to write it in log form. Now I know it says logarithmic. We just like abbreviate stuff as logs. Where are logs used? Richter scale, measuring earthquakes. Okay? Seismic activity. So when I look at this, and they're going to be used a lot in compound interest problems when we talk about growth of solving for time and figuring out how long it takes until your account can reach a certain balance. So remember, our base is going to go here. I'm even trying to keep everything the same. Arguments, we highlighted in orange. So the argument or the a value goes here. And logs equal exponents. So whatever the exponent value is, that's going to go here. So remember, the base, the argument, I'm going to call it the a value, and you're going to separate and bring it over here and put the exponent. Okay? So the exponent's the easiest one to find. What's the exponent here? The exponent's 2. Okay, so in this box, the 2 is going to go there. Our base, well, the base is at the bottom of the exponent, so the base is 14, so we put that at the bottom of the log. So 14 goes there. Kids, there's only one blank left. Do I even need to highlight that 196? I mean, that's the only number I got left to put in here. So 196 goes right there. Great, awesome. That's how you rewrite them. One's in log form, one's in exponent form. Did they ask you to do anything else with them? Not yet. Awesome. So let's flip it over. Here, what does it say to do? It says, hey, just evaluate the following logs. Log base 7 of 49. Didn't we already do that? Log base 7 of 49. What is log base 7 of 49? What did that thing equal? Oh, this thing equals 2. Why is it 2? Because 7 times 7 equals 49. How many 7s did we use? We used 1, 2. That's one way to look at it. Or 7 squared equals 49. So the reason it's 2 is because it takes 2 7s to get to 49. Don't tell me the answer is 7. Oh, Dasher, 7 times 7 is 49, so the answer is 7. No, it's how many 7s did you use? Okay. We already did 14. We said the answer was 3 because the exponent of the exponential equation would have to be 3. 3 to the third is 27. Okay? Now, here's something that I need you to know. Okay? Because maybe when you look at this, you're like, oh, okay, here's the base 7, base 3, base 12, base 3, base 2. Down here, base 64, base 9. I don't know how to do 15 because there's no base. So here's what I want you to do when there's no base. If there is no base, if there is no base, it's a 10. If there's no base, it's going to be a 10. So this problem is actually in base 10. Okay. So just like, hey, remember on your variables, if there's no number out front, we said there's a 1. On a square root, if you don't see the number, remember it's a 2. On a log problem, if you don't see the base number, it's a 10. Because base 10s are the most common. This is called a common log. This is called a common log. Common log. Okay, common logs have base 10. So why are they called common logs? Because base 10 is the most common thing to count by. What do you count by? You count by 10s. No, I don't. I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then what happens at 10? You start over and count another group of 10s. Why do you count by 10s? Probably because you have 10 fingers. So that's why they consider it common. Common logs have base 10. So what is the answer to this? The answer to that's 2. What? Why is it 2? Because how many 10s does it take me to get to 100? 2. Remember, what exponent would you use with 10 to get you to 100? It would have to be 2. So the answer to that log problem is 2 because 10 times 10 is 100. 10 squared is 100. Okay? All right. So in part 2, we'll look at how to do that on a calculator.